So today's experiment is E4, and in this experiment we will actually study the capacitor characteristics when it is connected in series or in parallel circuit. For this experiment actually we need few things: capacitors, and we are using the capacitors of 0.1 microfarad and 2.2 microfarad. These are the capacitor actually. This one is the capacitor. Beside that, we need power supply here. It has two parts. One is DC and another part is actually AC. So we need actually AC power supply. So here we will use the power supply. We need multimeter to find out the voltage or the current. We will use the multimeter. As we are using the AC power supply, of course our multimeter need to be set in AC range, actually AC voltage range. And we'll do this experiment on these breadboards. I hope you all know how the breadboards work. I already have two capacitors. Both are 0.1 microfarads actually. And we'll do this, actually we will do first the series. When these two capacitors are connected in a series. So how we will do? Let's see, this is my breadboard. We kept it same line. See, it's on the same line. So these are the series connected. Now we need to put the power supply voltage. So connected, we are connecting it to the voltage. Okay. So now we are set. So we are set. Now my voltage is kept in 0 volt here. So first increase the voltage. Now measure the voltage. What is the voltage? Input voltage. Input voltage. How much is showing? It's showing 10.34 volt. So we will keep this. We'll write it down. What is the power supply? Voltage power supply, VPS, equal 10.34. 10.34 volt. Okay. So we need to actually find out when it is in series. C1 and C2 is in series. So, and we need to find out the equivalent capacitance when they are in series, and from the experiment we will measure the voltage across the capacitor 2 actually. So now let's do these things. So now we will measure the capacitor, actually capacitive voltage across the capacitor C2, that means across this capacitor, this one. So measure this. So it's giving around 5.88 volt, and write down this voltage, the value of this voltage 5.88 volt in this. So this is actually done. Now the thing is, we need to find out the expected voltage from the calculation. We got 5.88, and you have to find out the V2 from theoretically the V2 is your calculation. If we do this, V2 equal C1 divided by C1 plus C2 VPS, source voltage. So if you plug the values of C1 and C2 and the value of PS voltage source, source voltage, then you can calculate the V2. So fill it out with the calculated voltage V2 and compare these two voltages. So that's all. So in our next experiments, what we will do, we will keep the capacitor C2 and C3. Actually, this is my C2 and I am taking the third one, which is the same value and 0.1 microfarad, called it C3, and we will keep this C2 and C3 in parallel, and the previous circuit C1 will be series with these two. So what should we do? Take off this, Actually, this is the second circuit where C2 and C3 are parallel to each other and C1 is in series at the same way. So we just need to find this. Okay, take the breadboard up. No, parallel. এটার সাথে parallel না, অন্ধকার হয়ে যাচ্ছে। So now these two are parallel to each other and this one is in series. Okay. So now give the connection. Turn on the power supply. Again, we need to find out the voltage across C2. Actually, it's not only C2, it would be C2 and C3. And what is the voltage? Now, when we are measuring the voltage across C2, let's see C2, then we are getting 3.91 volts. Previously, we got it 5.88. Now it is 3.91. 3.91 volt. So exactly the same way we will do the theoretically, we will calculate the equivalent capacitance of C2 and C3 and expected value of the V2 from the theoretically. And we will compare these two, theoretical and experimental measurements. We will compare these two and write down the error calculations. So in our third part, what we will do, we will do the same circuit but the different capacitor. Previously, all three capacitors are 0.1 microfarad. Now we will use the C3 as 2.2 microfarad C3. So still C2 and C3 are in parallel. Still, just a second. C2 and C3 are in parallel, but now C3 is 2.2 microfarads only. So now let's see. Measure the voltage across C2. So now it's showing the voltage actually decreased again. So it's only 0.51 volts. So the measured voltage is here 0.51 volt. So what we see here, let's say when it was in series and we measured the voltage across the C2, we got only 5.88 volt. When we connected another capacitor, the same value capacitors, the voltage across C2 decreased and it became 3.91. And when we change the capacitor from 0.1 microfarad to 2.2 microfarad, then the voltage more decreased and this is 0.51 volt only. So now we will do the same experiment in series what we started with the three capacitors C1, C2, both are 0.1 microfarad, and C3 which is also in 0.1 microfarad. 1, 1, 2, 3. You have the all three here. So now give the power supply. The voltage is here. Now measure the voltage across V2 and V3. Actually, we should have keep it here.
V3.
V2 and V3.
Okay.
So we are getting the voltage across the V2 and V3, and that is showing 7.04, which is 7.04 volt. V2, V3, we are measuring the. We can actually think any one is V1, V2, V3 because they all are same now.
So let's
Same, actually, almost. So around 7 actually we can say is the voltage. So again, we measured only the voltage, this part. Now we need to do the calculation for this part theoretically. All the equations are given in the theory part, and we need to find out the expected value from this graph, and your work is to compare these two actually. Main part of your work is to compare these two and find the error within your measurements. That's all. For our second experiment, which one is actually for the table number 2, to complete that experiment, what we will do, we will keep the same diagram actually, same figure where C1 and C2 is in series. We will have the voltage power supply here, and we will measure the voltage across C. So here you will get an unknown capacitor here, and you will get the voltage. You have to measure the voltage for the known input voltage, for different input voltages actually. So you will change the input voltages from the power supply. What you know from here, actually you will change the input voltage, and you will check the output voltage of across that unknown capacitor, which is, this is our that graph. We will change 1, 2, 3 number of 3 times. So we will change that our power supply voltage, and we will measure the output. So let's start this thing. So our power supply voltage, here we measure the supply voltage is 3.48. So we are writing it 3.48. 3.48.
Unknown.
And unknown voltage, we are measuring 0.16 volt. 0.16 volt. Now again change the voltage. So here we are getting the measurement 6.94. So 6.94 our power supply voltage. And what is the unknown voltage here? We measured the unknown voltage 0.32. So now we have changed again our power supply, and now our supply voltage is 10.41. So we are writing it down 10.41. Now let's check the unknown voltage. So unknown voltage is 0.49. 0.49 volt. So now using this voltage, measured voltage and the supplied voltage, you can find out the unknown capacitor C2 using, of course, you have the theory there back in your theoretical part. So you find out the C2 for unknown. Actually, it's not C2. Find out the unknown capacitor and find out the mean of this unknown capacitor. That is your calculations part.